Good evening everyone, my name is Rahat Naz. Today I am going to cover Chomsky hierarchy topic from TOC, and where we have to study 4 type of machine, that is type 3, type 2, type 1 and type 0. As you can see, type 3 machine is known as finite automata machine and it deals with the regular language. Type 2 machine is known as the push down automata and it deals with the context free language or context free grammar. Type 1 machine deals with the linear bounded machine and it deals with the context sensitive language. Type 0 is unrestricted and it is basically Turing machine. Now type 3 finite automata has limited memory. It cannot move backward, it only move forwards. Type 2 machine is way powerful than type 3 machines, that is push down automata, and type 1 machine is powerful than type 2 machine, and most powerful machine is Turing machine. Now coming to the most important point, if a certain grammar is given and you have to determine which type of machine or which type of grammar it is, then first you have to easiest way to find out is to find out the type 2. That is, what is the condition of type 2? The left hand side must be a single non-terminal. So if a grammar is type 2, by default it is type 3 and so on, right? Now moving to the next topic. So this is the rules for the type 0. Type 0 is saying u tends to v, and that is u left hand side at least one non-terminal. That means if I say non-terminal means at least left hand side must have one capital letter. If I say small a tends to capital B, capital S, then this is wrong. Now coming to the type 1, what is the rule for the type 1? Type 1 is saying the length of left hand side must be less than or equal to the right hand side, right? Now there is one more condition here you have to follow. Except the starting symbol, no other production rule can produce null, right? Now coming to the type 2, as I mentioned earlier also, type 2 is saying that u, that is the left hand side, must be a single non-terminal. As I said, I have already discussed what is non-terminal, terminal in my previous video. If you have not watched it, kindly visit my previous video and then come back to this video, right? And the type 3 is left linear or right linear. If the expression is v tends to vt star plus t star, then it is left linear, and if it is v tends to t star v plus t star, then it is right linear. I will explain you in detail, so please don't get afraid of it, what it is. Now coming to the finite automata. Finite automata is having the limited memory and it is the type of type 3 machine. It deals with the regular language. Now there are 2 type of finite automata: deterministic finite automata, non-deterministic finite automata. If there is an input type A, B, A, B, A, then we move forward towards the right hand side. We cannot come back to, if we are reading A then B and then A then A, we cannot move back to A again because it is having the finite memory, right? It is having the limited memory. After reading each symbol consecutive, we are moving to some state. Suppose from Q0 state we want to move to Q1, we are reading a symbol A, and so on. Only forward movement is allowed in finite automata because of limited memory, no backward movement. I hope it is clear to you. Moving to the next part, that is how to determine their type. Suppose it is given S tend to A, S, B, A. So these are the 3 questions which I want all my students to solve and send me as in the form of assignment, that whether it is type 3, type 2, type 1 or type 0, as I have already discussed the rules to determine type 3, type 2, type 0. But firstly I would suggest, whenever you are finding any types, start with type 2. Now coming to the DFA and NFA theory. So DFA and NFA theory, there are certain terminology that you have to start. Q naught, that means Q and 0 suffix is always the start symbol, and Q double circle is always the final state. Now this is the transition table, which is very important in terms of your syllabus. In first input and state is given Q naught and QF is the state, A and B is the input symbol. If you are reading Q naught A, you are moving to final state. If you are reading Q naught A, you are being, see, you can see from here, it is very clear. While you are reading Q naught and you are reading the symbol A, you are moving to QF. And in QF, whatever alphabets you are reading, A or B, you are coming to the same state, which is mentioned here. So this is how you can draw the transition graph. That is the transition table, and this is the transition graph. So now we will discuss the deterministic finite automata. What is deterministic finite automata? First of all, to understand deterministic finite automata, you have to understand this 5 tuples definition. That is, Q is the set of states. Suppose if I have n state, then Q naught 1, 2, 3 until QF. Sigma is the input alphabets A and B. This is the transition function. While reading Q naught, while you are in Q naught state and reading symbol A, you are reaching to Q1. This is how you can show the transition. Now, in deterministic finite automata, you can see from Q naught, while you are moving to Q1, either you have to read A or B, but the thing is that once from Q naught, A alphabet has been read, so from Q naught, A cannot be repeated. In each state, only once A and B will be used, it cannot be repeated. Only one choice and only one transition, right? And secondly, in Q naught, if you are using A to reach to Q1, and you cannot miss B. Here you are reading B to reach Q2. So there is no dead configuration. There is no two choice. There is no dead configuration. And thirdly is that there is no null moves allowed in DFA. On the other hand, in NFA, you can use the null moves. If you want to reach from Q0 to Q1 and there is no symbol available, you can use the null moves, and dead configuration are allowed. What is dead configuration? From Q0 to Q1, if you want to move, you are using A, but there is one more alphabet given B, but you are not using B to reach anywhere. That is called dead configuration, which is allowed in NFA, right? So Q0 is the starting state, QF is the final state. So these are the certain points which I have already mentioned. Now you can see in non-deterministic finite automata, in Q0, while you are reading A or B, you can read on this, you are in the same state. But see Q0, there is no symbol B. You can see Q1, B symbol is used, but there is no A symbol used. In Q2, similarly, there is no use of A. So these are the dead configuration, right? And see, you can see Q0, A has been used for Q1 and A used for the self. So this is not allowed in DFA. So these are the certain things you have to remember. And for the further class, we will read some more important topics.